Alright, so sometimes when you're doing absolute value equations, you'll get these answers that don't really make any sense. So, in that case, we want to look at what the solutions are and how we're actually checking our equation. This is 2 times the absolute value of x minus 3 minus 1 is equal to negative 5. So the first thing I would do to solve this one is to add 1 to both sides. Once I add 1 to both sides, my negative 5 plus 1 is going to give me a negative 4. And then on this side, the negative 1 and the positive 1 cancel out. So I'm left with a 2 and an absolute value of x minus 3. So now at this point, I want to get the absolute value by itself on the left side. So I need to get rid of this positive 2 right here. So what I can do is, I can divide both sides by 2, since I know that's the opposite of multiplying by 2. Notice how we're multiplying by 2 here. So I'm doing the opposite, dividing by 2. Once that happens, the 2's actually cancel out. And I'm left with x minus 3 on this side. And when I divide by 2 on this side, I get negative 4 divided by 2. That's going to give me that negative 2 that I want. Okay. So at this point, I have x minus 3 inside absolute value bars, and if I continue to solve this equation the way it is, and by the way, this is no solution, once you get to the point where you see that absolute value is equal to a negative number, that is no solution. There's no value of x that can solve this. But if I was to continue on, like I know I should be able to take this x minus 3 out of the absolute value. And then on the other side, I could have a positive 2 or a negative 2. So I could have this, or I could have this. Right? The only thing that's changed is the right side. The number could be positive, or it could be negative. But the absolute value expression, that's going to stay the same. So now I solve both for x, adding 3 to each side, like this. And I get x equals 5. Over here, I'm going to get x equals positive 1. So I have two solutions, 1 and 5, right? I put them in my solution set. So now what I can do is, I can check these two solutions to see if they're right. If I want to check the first one, x equals 1, then I'm going to take my original equation that I started off with, and I'm just going to plug in x as 1. So I get 2 times the absolute value of 1 minus 3, minus 1 on the outside, equals negative 5. And then over here, if I'm testing out the x equals 5, I'm going to have 2 times the absolute value of 5 minus 3, minus 1 on the outside, equals negative 5. So what happens here? Well, on the inside of the absolute value, I'm going to get a negative 2. Right? Because I'm doing 1 minus 3. And then over on this side, let me finish this off. But on the other side, I have 5 minus 3. That's going to give me positive 2 on the inside. Everything else stays the same. So now at the very end, I'm going to take the absolute value of negative 2 to get positive 2. And then over here, I take the absolute value of positive 2. That stays positive 2. So I'm going to have 2 times positive 2 minus 1 equals negative 5. Okay, so now I'm almost done. I get 2 times 2 is 4. On both sides, it looks like. Yep. 4 minus 1 equals negative 5. And then for both of these, I run into a false statement. I get 3 is equal to negative 5. For the next one, I get the same thing. 3 is equal to negative 5. Well, since these are false statements, then these two solutions don't actually belong in the solution set. So I get rid of them. So sometimes when you get solutions to these equations, you're going to get some solutions that don't really work out when you check them. And you can call those extraneous solutions. Extraneous solutions. But they're not actual solutions. So that's why when we write our solution set for these, we can write the empty set. Sometimes it looks like that. Or sometimes I'll use the symbol of an O with a line drawn through it. That's also the empty set. Or I could just write no solution. Same thing. Now, I wouldn't have to do all this work if I had just recognized that I have -2 on the other side of this equation, right? And the absolute value of any real number can never be negative. So that's how I know this is no solution when I started. So I hope that helps.